famous person, Professor V. Chandrasekhar, amongst us. When we think of chemistry, or I say that more specifically inorganic chemistry, like the organometallic chemistry, supramolecular chemistry, or the chemistry of inorganic clusters, rings, so on and so forth, the name first comes to our mind is none other than Professor Chandrasekhar. And it is probably a very difficult task for me to introduce such an eminent scientist within just 3 to 4 minutes. So I will say in a nutshell that Professor V. Chandrasekhar is now the Center Director of TIFR Hyderabad, as already Principal Maharaj has declared. And after his decades-long journey in IIT Kanpur, from 1987 to 2012 as their professor and dean of faculty affairs, and he was also the center director of NISR. Professor Chandrasekhar is the elected fellow of several institutes of international and national repute, like Indian National Science Academy, National Academy of Science of India, World's Academy of Science, Indian Academy of Science, like that. He is also the recipient of the most prestigious Shanti Swarup Bhatnagar Award in 2003 for his prominent and prolific contribution to the chemical science. He has also received several other awards and honors, like Young Scientist Medal in 1989, CRSI Bronze Medal in 2002, CRSI Silver Medal in 2011, the J.C. Bose National Fellowship, etc. He has produced a galaxy of eminent research fellows, and his work is mainly focused on synthesis of organometallic compounds, like the organotin clusters, multimetallic assemblies, cages, supramolecules, etc. He has published several research papers in journals of high scientific repute. With these very few words, now I would request our most respected Professor V. Chandrasekhar sir to kindly deliver his talk. Sir, please.
Thank you. Thank you very much for your very kind introduction. I am very happy to be here to share this evening. And since this lecture was supposed to be like an inspiration lecture, I am giving on, since this is the 160th birthday of Professor P.C. Ray, I thought I'll reflect to you, particularly the young students, how chemistry developed in India, starting from P.C. Ray to now, and what are the prospects in terms of chemistry has for the country as a subject in terms of economy and so on. Before I start, of course, I am very thankful for this opportunity, particularly since this is a college associated with Sri Ramakrishna Paramahamsa. Many of my students at IIT Kanpur have come from one or the other college associated with this. And I myself have visited Dakshineshwar several times. So this is a very nice opportunity for me to interact with you. So let me just start by sharing my slides. I hope you're able to see this. Okay. So you're able to see my screen, right?
Yes, sir. Yeah. Perfectly.
Okay, fine.
Perfect.
Thank you.
Yes,
so, right. So the title is Development of Chemistry in India, particularly independent India. But the independent Indian development has a backdrop, and the backdrop is in terms of the chemistry. In fact, the first school of chemistry developed in the country by P.C. Ray. So let me just get started. In terms of, somewhat it looks obscure to start from this particular place, but this has got a reason. Now, this is, of course, the famous iron pillar in Delhi, located near the Qutub Minar. And this iron pillar, the age of it is really not a matter of for us. One can debate it. Is it 2,000 years, 1,500 years? Does not matter. It's a very old structure that is there. That is sufficient. But the most important part of that is this is just pure iron. It is not steel. And this iron pillar has remained like that, withstanding the weather extremities in northern India. Uh, lots of rains, lots of humidity, and the hot suns and so on, and not rusted. So, which kind of tells you that Indians had a connection uh, with metallurgy, and metallurgy, of course, has an intimate connection with chemistry in terms of how do you, for example, get the pure metal out of the ore, what are the additives you add to make it better, and so on. So the iron pillar itself has a very interesting sort of a recent connection with IIT Kanpur, where I worked most of my professional career. And in fact, a colleague of mine, Professor Balasubramaniam, who was in the Department of Materials and Metallurgical Engineering, um, worked a lot on finding out the precise scientific reasons why this iron pillar is corrosion resistant, and his investigations have been published in several journals and also a book form. And so what he found out was that there is a layer of phosphorus. That is, phosphorus was an additive during the processing of iron, and ancient Indians knew this, and this allowed a protective layer of iron oxide hydroxide to be formed. Precisely, if you're more interested, it's a delta form of it next to the metal surface, and this then allows corrosion resistance. So, in addition, of course, it also forms iron hydrogen phosphate hydrate, which is another thin layer next to the metal oxide, and these two result in protecting this iron from getting corroding. So the point of this is that chemistry knowledge in medieval India was reasonable. Particularly we had knowledge in variety of things. Like, for example, definitely gunpowder was used by several of the thousands of kings that were there in India. We knew about medicines, if not synthetically, but at least natural products that you could extract from natural sources, things that were used as medicines. We also knew about, again, dyes, which are again natural, and also detergents from natural sources. There was a reasonable knowledge of chemistry. And in fact, before I start the story on PC Ray, PC Ray did a very remarkable thing. He did what can probably be told as the first authentic research on what is that Indians knew in terms of chemistry. And he had these two volumes that he published and called The History of the Hindu Chemistry in 1902, the volume 1, and volume 2, 1908. So to do this, he had to really actually read Sanskrit, and he had to learn Sanskrit and Pali, and it was a massive exercise. He researched for 12 years, and he also had to kind of fight two very dogmatic schools, which are prevalent even today. So one set of schools are the so-called Indophiles. Now, these people would tell you that we knew everything. There was nothing that Indians did not know. And therefore, everything that is now present is already there in our Vedas, so there's nothing new for us to learn. The other set of school are the Anglophiles, who would say that Indians knew nothing. Only after the English came, we actually became civilized and knew even the most basic things. So Ray had to fight these two extremes and tell people by proper research that while neither of this is correct, we had knowledge. It is not that we were perfect, and that knowledge was lost as time went by, and we had to catch up with the rest of the world later on. So his conclusion was that Indians had knowledge of acids, alkali, and had excellent knowledge about metallurgy, which was of course very clear. We had very, very good knowledge of metallurgy, and and at that particular point of time, disciplines were not, like as structured as today, and therefore metallurgy included things like what we would now call as chemistry. And but his most important conclusion was, even during the alchemy days, that is, for example, during the 1500s, 1600s, India was not really far behind. It's only after that we slipped completely, and we had to really relearn. And then, of course, the world has moved much faster. We were left behind. So P.C. Ray was the first person who would come back and establish a modern school of chemistry in the country. I will first start with this journey as a backdrop to what happened after independence. Of course, without any doubt, he is the father of modern Indian chemistry. Lived from 1861, where he was born, to 1944. So just before independence, he passed away, but lived a full life and lived a remarkable life where he served the society, the country, the community with great success. So, in honor of his great contributions, the Royal Society of Chemistry has established what is called as an international chemical landmark, and this is the first chemical landmark outside Europe. And this is now present in Presidency College, at that time Presidency College, now Presidency University, and this was put up in 2012. And what it says is to commemorate the life and achievements of Acharya P.C. Ray, father of Indian chemistry, also philanthropist, entrepreneur, and who founded modern chemistry teaching and research in India. Of course, there's one more thing that they could have added. He is actually the father of Indian chemical industry, because the first chemical industry in India was established by him. So let's just start his journey and understand what is it that he has done, from where he has come, and so on. So he was born in August 2nd, 1861, in a village which is Raroli Katipara, which is now in Khulna district in Bangladesh. At that time, probably it was in Jessore district, I think. I'm not sure about that. So, but it's very close to Kolkata, now in Bangladesh. His parents were, his father was a Jamindar, and they had 7 children, and he was the third child among 7, and nothing remarkable or unremarkable, a normal sort of a childhood that he had. But his father was quite keen that his children get a good education, and since in the place where they were, this was not available, they thought that they have to bring this child to, at that time, Calcutta, now Kolkata. So this is basically where his native place is, and there is a Acharya Prafulla Chandra Ray museum there. And so his father brought him to Kolkata for education, because he thought that here is where his sons can get educated and have a better future. So his education got started, and of course, when he came to this, what we now call as intermediate, and what at that point of time was called the first arts, or FA. So he was entered, and in this, he joined this, what is now called Vidyasagar College, at that time Metropolitan Institution, founded by Vidyasagar College, where there were some fantastic people, including Surendranath Banerjee, who was a lecturer. So very inspiring people were there. Chemistry was a compulsory subject. So, but they had, even though this particular degree is called First Arts, chemistry was a compulsory subject. And because chemistry involved practicals, and because Metropolitan Institution did not have any lab facilities, they had to go to Presidency College to conduct their practical, all their practicals. So this is how, of course, Vidyasagar College looks today. And the lectures on chemistry and also practicals of chemistry were at the Presidency College, where there was a very influential chemistry teacher who was later to become the Vice Chancellor of universities in India, and who was later knighted when he went back to UK. This was Alexander Pedler. And Alexander Pedler had this very beautiful way of teaching, which lectures would be coupled with demonstrations. So this is basically the way, the European way of teaching chemistry. Even now, in Germany, for example, their lecture halls are equipped with capabilities to do practicals right in the lecture hall. So you're teaching something, and you can demonstrate what you're teaching through an experiment right when you're lecturing. So that was the method adopted by Pedler while he was teaching chemistry to the students. And P.C. Ray immediately knew that this is what I want to do. And he joined for BA at Presidency College, but he had this great ambition that maybe I should go abroad and study at the best places. Then I will be trained in the best possible place. Then I can come back to the country and serve the country in a better manner. So one of the opportunities that came by his way was this Gilchrist Scholarship. Now, there were only 2 scholarships in a year, and when an advertisement was placed for 2 scholarships, he applied. There were written examinations and whatnot, and he stood fast, got the scholarship, and this gave him an opportunity to go to University of Edinburgh to do his further studies, where he first did his Bachelor of Science at University of Edinburgh and with a specialization in chemistry. So and this was done, he completed his bachelor's, and then he had this ambition to continue and do a PhD. So when he wanted to do a PhD, the question that he had to choose himself, what is it that he had to do? So chemistry was slowly kind of getting developed into the forms that we know now. That is organic chemistry, inorganic chemistry, and physical chemistry. Organic chemistry already took off quite well, even by the time PC they went to Scotland. Already Kekulé, for example, discovered this bonding in benzene. There were several very important organic chemists established in Germany and also in other places in France and also in England. So he thought that organic chemistry is already somewhat developed. In contrast, inorganic chemistry at the time was still kind of very vague. In fact, even today, for example, if you ask students which do you like, organic or inorganic chemistry, I'm 100% sure most people would say I like organic chemistry, which is more systematic. Inorganic chemistry, we seem to be, we'll have to kind of memorize a lot. It doesn't seem to be a systematization. Every element seems to be different and so on. And they're partly correct. So, but Ray was attracted to inorganic chemistry precisely because of this. So he thought that this was very challenging. There were many unanswered questions, and that therefore gave him an opportunity to do research because it is still completely unexplored. So he carried out what is called as an independent DSC work. That means he had to choose the problem himself and work on it. There will be a formal mentor, but that mentor is only for the purposes of really assessing you whether you are going in the right direction or not. It's not like a guide in a PhD thesis like we know of today. It's a completely independent work. So he had to search his problem. So the way he searched his problem was at that time, there were these compositions which were called as double salts. I mean, today, of course, we know that, let's say the famous example is Morse salt. There is an iron 2, and there is an ammonium 1, and there is sulfate. So today we simply know that, yeah, these are there because you have this iron with the 6 water molecules that are coordinating around it, and the sulfates and ammoniums are hydrogen bonded, and therefore they stick together. But at that time, they were still called the double salts because they would crystallize together in that composition. And today we know the reason for crystallization together is because of the strong interaction. So these were known. Double salts were known, and several of them were known. There's a monovalent ion, which is like, for example, ammonium or potassium or so on. And there is a divalent ion, typically, let's say, a transition metal ion, like in the example of Morse. But in addition to this, there was a claim by a person called Wohl that you can have a double salt. That is double sulfates. So one is already which is established, but in addition to this, you also have perhaps by crystallization such entities where you have this composition of, being fixed and being crystallized all continuously. That is, whenever you do it, this is the composition it crystallizes. There was an investigation later on by these 2 people who were not convinced that this was the right claim, and in fact they published a paper disputing their both claims. So Ray felt that this was an opportunity for him to really figure out which is correct. And then so his investigations led him to conclude that this molecular double sulfates with variable but integral x and y. So for example, there could be x and y, but the value of x and y may be different. That is basically what his conclusion was. Unlike what is written here, it's a 1:1 composition. and he published this paper and submitted his thesis. Of course, today we know that all of these reported molecular double sulfates are really not molecular; they're just solid solutions or mixtures. But Ray did not have the access to the instrumentation that we have, and all that he had to rely on was only analytical methods. But be that as may, his thesis was really appreciated in this university, and he was in fact given a prize called the Hope Prize, which allowed him to work for a further period of time. And this time he worked with Professor Alexander Crum Brown, who was a very established organic chemist. So this influence of organic chemistry remained with Ray for throughout his research career. And in fact, during the last part of his research, he worked extensively on some derivatives of organic, for example, thiocamphor or fluorinated derivatives and so on. So, in addition, of course, getting trained at one of the best places in the world, knowing really where chemistry is going, he also had a very competitive mind in terms of participating in activities around him. And there was an opportunity for him to participate in an essay competition. And so he wrote, this is the essay competition on, actually the subject was India before and after the mutiny. So I think the idea of the subject was to highlight, particularly in sense of the fact how much the British government had done to enlighten India after the mutiny, because the word used also was the mutiny and not what we now know as the First War of Indian Independence. But Ray had a very interesting take on this, and he wrote a beautiful essay. And he said that the lamentable condition of India is due to England's culpable neglect. The part played by England in intellectual progress in India, so he does acknowledge, is the brightest chapter in Anglo-Indian history. England, unfortunately, now does her best to strangle the nascent aspirations of a rising nationality. So, of course, they said definitely with this kind of a language, they said did not get the first prize, but the judges did acknowledge that the essay has bearing marks of rare excellence, and it was bracketed in the second category. But this already kind of gives you an idea of the making of a future nationalist, and when Ray were to come back to India. So he returned to India in 1888, and he was looking for a job. And the jobs are not easy to obtain, particularly supposing you are well trained in chemistry. There is no chemical industry, there is no chemistry teaching. So where do you get a job? So the British Education Department at that time had two services called the Provincial Service and the Imperial Service. The Imperial Service paid double the salary of the Provincial Service, but was open only to the Europeans. So it was quite clear that this is not available for people born in India or of Indian origin. But Ray was, in fact, even considering this discrimination, he was lucky to get the provincial service, and he joined Presidency College under the provincial service as assistant professor. And the salary was really not so bad. I mean, it was half of the imperial service, but 250 rupees in 1889 was in fact a princely sum when you consider that probably gold at that time ranged between 8 to 10 rupees for 10 grams. So you can imagine that this was a pretty decent sum. In fact, a princely sum as a salary. So he worked for until he retired. He retired at the age of 55, and in Presidency College. Then Sir Ashutosh Mukherjee, who was the Vice Chancellor of Calcutta University, obtained donations from private donors and established two chairs, one in physics and one in chemistry. And he invited Acharya Ray to take up the Palit chair in chemistry. Of course, the other chair, Palit chair, was taken up by C.V. Raman, who won the Nobel Prize while working at Calcutta University, but doing his research at the Indian Association for Cultivation of Sciences. So P.C. Ray worked at Calcutta University for 20 years, and finally, when he quit, he was at a very ripe old age. Till that particular age, he was working. What did he do when he was at the Presidency College? So he had learned this technique of lecturing with demonstrations while already he was when he was a student, and so he was a great proponent of this technique of doing lectures with demonstrations. And also he knew about the various prejudices and the lack of scientific temper among the Indian common public as well as general students. So he would conduct even demonstrations such as, for example, heat a bone and show that the residue is simply calcium phosphate that you can get from other sources also. So he would do all kinds of these kinds of experiments with a dual purpose. And his class had many luminaries. I mean, just to point out two people, Meghnad Saha and Satyendranath Bose were students of his class. And in fact, the first school of chemistry in the country was established by Ray, because you can look at the type of people. J.C. Ghosh, who was at Indian Institute of Science, Bangalore later, he actually was also director of the ISC for a short period of time before he was invited by the government of India, that was the independent government of India, to be the founding director of IIT Kharagpur, was one of his students. Then Panchanan Niyogi, who was the principal of Raja Manindra Chandra College. Then Neil Ratan Dhar, physical chemist, was at Allahabad University. And the first person to start biochemistry in the country, B.C. Guha. Then P.R. Ray, who is known for his Ray Dutt Trust. And even Bhatnagar, who was later to establish the Council of Scientific and Industrial Research in India, was in fact his grand student, if not his student, his grand student. So this is one photograph of, with all his students. You can see PC Ray in the center. And there are many famous people, but of course, the most famous of them is S.N. Bose and Meghnad Saha. But there are other people who are really also quite famous, like this is J.C. Ghosh and so on. So these are, students who, for the first time, worked in a systematic manner and learned chemistry under his tutelage. Now, unlike what might be thought about him, Ray was a prolific researcher. Means he worked from the day he joined at Presidency College till he formally kind of hang up his boots in Calcutta University. He worked continuously on all the contemporary problems in inorganic chemistry. And his publications range more than 150. And he worked on several things: nitrites and hyponitrate compounds, organic compounds containing sulfur, and fluorinated organic compounds. And I'll just take you through some glimpses of it. You might already be knowing some of it, but just some glimpses of it. And also kind of point out to you the difficulties at that particular point of time to establish structures, because there were no structural techniques that were available, no spectroscopic techniques available. So people have to use techniques like electrical conductivity, composition by analysis, and so on, and then come up. So it was so much more difficult to work on these systems and to establish their structures. So this was one of his big breakthroughs, the mercurous nitrite, which he could prepare by reaction of mercury with nitric acid. And in fact, Professor Animesh Chakravarti, who was at ISAS, repeated these experiments much later and published the structure of this compound. So the structure of the compound was determined several times later, and the most recent being Professor Animesh Chakravarti, who determined it. And this is how the structure looks like. There is a mercury-mercury bond, and this nitrite binds to mercury in a chelating fashion. Of course, this was Ray did not know about this, but he correctly formulated the structure. And later this kept him, and this was such an important work that this made him overnight very famous. Very important people from Europe wrote to him letters congratulating him on this achievement. And this kept him busy for several years at Presidency University, and later also at Kolkata University. So he worked on nitrites, nitrates, and various other coordination complexes, some of which I'm showing today, like for example, this chelating bipyridine along with nitrate ligands, 4 nitrates around mercury. So you have both mercurous and mercuric type of compounds that he did. And another remarkable experiment, which is really, quite fantastic, was at that time among ammonium salts, only ammonium chloride could be sublimed, and you could find out its vapor density after you sublime it. So Ray could, because this was a very, very sensitive compound, but Ray could use skills available at that time in Kolkata to build apparatus and sublime this compound, and then after careful sublimation determine its vapor density and establish its molecular nature. In fact, Nature in its 1912 issue, the commentator of Nature even does it today. So for example, there is important science published, they take up selected publications and there is a commentary on that work. So similarly, in that particular time that they wrote, a further accomplishment means already they have acknowledged that he has accomplished a lot. A further accomplishment in determining the vapor density of this fugitive compound. After this, of course, he then looked at a number of other things. So if you look at it, all of his investigations are on the heavier sort of metals. So he looked at how does sulfur bind? Can I have thiolates binding? And so one of the very remarkable postulations he made was this mercury in the tricoordinate sort of a state. So this was later proved by X-ray structure and iridium compounds. So I will not take you through all of this because this is accessible. And if you're not, please read up Professor Animesh Chakravarti's publication, which highlights these contributions of Professor P.C. Ray. I'll give you the reference towards the end of this talk. Actually, right here, in the next few slides, I will be giving. But just to give you the representative publications of P.C. Ray and where he published. On mercurous nitride, he published first in the Journal of Asiatic Society of Bengal. And on this vapor density of ammonium nitrate in the Journal of Chemical Society Transactions is published from UK. On the fluorination of organic compounds, he published in Nature. This is 1933. Monofluoroacetone, the preparation of monofluoroacetone. On the synthesis of thiocamphor and other cyclic thioketones, he published in Nature in 1934. So the publications are in fantastic journals, and both in terms of quality and quantity, and in terms of training people, he was at the forefront. And in fact, he was, when he went for a lecture tour, already everybody in the Europe knew him and about his work. In addition, of course, he took many initiatives. So he realized that in order for this chemistry as a discipline to flourish and thrive in the country, you need to have a professional society. And so he built this professional society for chemists in India. He created this Indian Chemical Society. It's unfortunate that this society has really not lived up to what he wanted it to become. And the society published the first research journal, the Journal of Indian Chemical Society. Again, it was a very good journal to begin with, but slowly declined now into almost obscurity. So the other facet of Acharya P.C. Ray was this knowledge that he had that chemistry, unlike, for example, physics, has a real direct connection in terms of its translational capabilities. It is much quicker to translate chemical knowledge and put it to use to society. And this he already knew while he was in Europe. He saw many examples of this. So, and he also knew that at that particular point of time, there was a real fervent movement in the country for independence. But he knew that economic independence is a prelude to political independence. It's not sufficient just to be politically independent, and if you're economically dependent on outside sources. And he also knew that science is the key to drive the country's progress if scientific knowledge can be translated to industry. And he had several examples from personal knowledge in Europe and America. So in his house in 91 Upper Circular Road, now which is called as Acharya Prafulla Chandra Ray Road, he started to make many indigenous medicines, chemicals, various things that he thought, for example, can be used. For example, he just took rust, iron rust or rust particles, then with the combination with sulfuric acid, prepared iron sulfate and sold it to people, and so on. And he established, actually, by the time he established his industry, Bengal Chemical and Pharmaceutical Works, it's a different matter that later on he got disenchanted with it and came out of it. But this was the first chemical industry in the country. And later it was taken up by the government of India when this company was not doing so well. I understand it has turned the corner. So hopefully it's financially viable. other facet of him was that he was a philanthropist par excellence. So he contributed money, contributed physical service in many ways. And Bengal, unfortunately, was always suffering from famine. So the Khulna famine in 1921, the floods in North Bengal. Not only Ray would work, but he also would motivate his students to directly participate in relief work, raise money, help the people, and so on. So, in fact, this direct participation of the of his students in many of these activities shaped their character. To give an example, one example only, Meghnad Saha, who was of course one of the most brilliant physicists, but later when he became a parliamentarian in independent India, was in fact instrumental in giving shape to the Damodar Valley Corporation. That is because of his experience in working for floods in North Bengal, and he knew how the floods are devastating and what can be the measures to control them. This is very well known. Professor P.C. Ray's, Acharya P.C. Ray's lifestyle, he was extremely Spartan to the point of like a sannyasi. He was single, extremely Spartan, and in fact, the last 20 years of his life, he lived in a single room without a ceiling fan in the university building at the University of Kolkata. And whatever money he was obtaining from this Palit Foundation as the Palit Chair of Chemistry, 9/10 of that money he would spend it on charity, or either on stipends for poor students or endowments for lectures and so on. And in fact, when he retired, all the money, nearly all the money that he had, which is 1,80,000 rupees in 1940s, imagine the value of the money if you compare to today's value, he gave it to Calcutta University to extend and develop the chemistry department there. And as I mentioned, he was also a great nationalist. And in fact, when the Rowlatt Act was passed in 1919, now this was the act where it suddenly kind of fired up all of India. And where, for example, a number of people protested against it. He said that I should leave the test tube to attend the call of the country, because science can wait, Swaraj cannot. But at the same time, he had very strong opinions, even though he was a staunch supporter of Gandhiji's non-cooperation. On issues where he differed with him, he did not hesitate to oppose him and tell him his views. So this was he, and he passed away after a full life on June 16th, 1944. And again, Nature in its July 15th issue of the same year commented that Sir Prafulla was more than anyone else responsible for the great development of not just chemistry research. This is really remarkable. They acknowledge that scientific research in India during the past 50 years. So this material that I took was from these articles, but primarily from the article of Professor Animesh Chakrabarti, who wrote the doctoral research of Acharya Prafulla Chandra Ray. This is an Indian Journal of History of Science. This journal is available on the web, and there is no cost to it. So people who are interested can download the publication and read it. Similarly, the chemical researches of Acharya Prafulla Chandra Ray, by again Professor Animesh Chakrabarti. In fact, there is a recent book that Professor Animesh Chakrabarti has written on the chemistry that carried out by Acharya Prafulla Chandra Ray, which is published by the Indian Chemical Society in Kolkata. So this was the backdrop of the chemistry scene. So by the time India became independent in 1947, we had some kind of fledgling groups of science, fledgling in chemistry, a little bit better developed in physics because there was a high profile person in the name of C.V. Raman, but also Meghnad Saha, and also Bose, S.N. Bose, and also J.C. Bose. So, physics was having a better sort of a spotlight on it, but chemistry, entirely due to one person, was there. So what happened post independence in India in chemistry? So of course, the first research institute in India was IACS Kolkata, not at its present location in Jadavpur, but in Bobajar Street in northern Calcutta, where in fact the most important research of C.V. Raman was carried out, and founded by Mahendralal Sarkar, India's first research institute. And but post independence, the two institutes that have really contributed enormously for scientific research in India One is Indian Institute of Science, founded before independence, 1909. The first director was a chemist, Maurice Travers. In fact, he was a student of William Ramsay, who was involved in the discovery of noble gases. And the Tata Institute of Fundamental Research, which is at, whose main campus now, in fact, I cannot say main campus because it's now distributed all over the country, but its original campus at Bombay, founded by Homi Bhabha. So these were the two most preeminent institutions which led a very important role in shaping Indian science post-independence. But there was also a recognition that India needs to step up on research. And therefore, several national laboratories dedicated to research were established. And this concept of research which has interaction with industry was very conscious. And Bhatnagar established this Council of Scientific and Industrial Research. And under its aegis, started to set up different different laboratories. This is the National Chemistry Laboratory at Pune, several laboratories, and today there are 37 of them. And then Jawaharlal Nehru and other people also recognized that India also needed its education to be at par with the best in the world. While we had very good universities at 1947, we had Calcutta University, we had Madras University, Bombay University, and so on. But he recognized that these are not sufficient. We have to step up our education and also have that education connected with technology. So in the 1950s, IIT Kharagpur was the first one, but later 4 other institutes. This is a picture of IIT Kanpur where I worked. And in the last, just like in the 2000s, 2010 onwards, we also have other institutions such as the ICERs, which have been established. This is a picture of ICER Bhopal. And of course, therefore, now we have several IITs, several ICERs, several central universities. So the Indian education system has ramped up. Now I will take you through how did chemistry perform and in post-independent India. And now this is a controversial thing. I mean, because there are favorite people of everybody, and somebody may say you left out this person or that person. I apologize already for my omission. I just took representative examples of what I thought were contributions of Indians in these areas which stand out. So this is first organic chemistry. I will not take each one of them. I just probably spend only a couple of minutes on them. But R. Venkatraman was the director of National Chemical Laboratory, established a very close linkage with the industry. And in fact, the chemistry environment that he generated probably directly or indirectly led to the now you can see this vigorous chemical chemistry based industry in and around Pune, in and around Bombay, and in fact going up to Gujarat. Professor T.R. Seshadri, a very famous organic chemist who worked in UK for his PhD, came back, worked at several places, but finally ended up at Delhi University and established a big school of chemistry, particularly natural products. More recently, I mean, in a sense, although Professor Sukhdev is 90 plus years old now and still continues to be alive and quite healthy, he was one of the very established organic chemists of the elder generation, worked for a long time in NCL Pune, and then later on in Baroda, and finally he was at ASAT Bhavnagar. Professor Kesar is at Punjab University. Professor A.V. Ramarao, who worked at the National Chemistry Laboratory and later at the Indian Institute of Chemical Technology at Hyderabad, and has now a chemistry industry in Hyderabad. And Professor Govardhan Mehta is in fact one of the most recent ones. One could say, compared to all of this, is just is a kid, and he has done research comparable to the best in the world in organic chemistry. I'll just take you through some glimpses. Not of everybody, but a couple of them. So Professor Govardhan Mehta, while he was at the University of Hyderabad, you can see from the quality of publications, Journal of American Chemical Society, and I just picked up 2 examples because I don't have time to give many, and another one in Angavan Tashimi in 1993. Now these are hydrocarbons. Hydrocarbons that you have to synthesize in this manner, there are no functional groups. And precisely with these geometries. So these are, the first one is the one that he called it as Garudane because of these wings. And the second one, he called it as a Golconda in honor of the 400th year of the establishment of Hyderabad, because it was the University of Hyderabad. And these were synthesis of the highest order. More recently, Professor Kesar, who belongs to really an excellent school of organic chemistry, published this paper where you have this organolithium reagent. Because of the presence of this nitrogen, has this lithiation adjacent to the nitrogen, and therefore you can have an electrophile coming in and have substitution adjacent to nitrogen. So this is like stereoselectivity and reactivity, which is promoted as a result of the nitrogen being there as the tertiary nitrogen, and that promotes lithiation, and then you have substitution adjacent to it. This is Professor A.V. Ramarao, who worked on a number of synthesis of a number of natural products, and one of his important contributions is in the synthesis of vancomycin, which is an antibiotic of the highest potency, where many antibiotics do not work. Vancomycin works, and you can see how complicated is this molecule with several stereo centers. And apart from this, of course, he's also very famous for establishing a protocol for the synthesis of the anti-HIV drug, which has been commercialized by Cipla and sold at an extremely low cost, particularly in African countries. Now, this is my colleague, Professor Vinod Singh at IIT Kanpur. And this is, he works on asymmetric synthesis, and you can see this involves preparation of compounds where among the two stereoisomers, you prepare only one of them in excess. Therefore, you have an enantiomeric excess. And this work was published in Angawantashimi a few years ago. So this is asymmetric alkynylation and lactamization cascade, an expeditious entry to enantiomerically enriched isoindolinones. And of course, we have inorganic chemistry, and inorganic chemistry already, because of P. Ray's influence, had a very good start. And of course, from Kolkata, you all would know Professor Animesh Chakravarti, who has established one of the most vibrant schools in coordination chemistry in the world. And many of his students are found all across Bengal and elsewhere in academia and also outside. Professor Bhatnagar, who was one of the original inorganic chemists in the country, was a magnetochemist. And Professor Mehrotra was among the first organometallic chemists of the country. And these three people are from Indian Institute of Science, where I did my PhD. And in fact, I was supervised by Professor Vasudeva Murthy and Krishnamurthy. Professor Vasudeva Murthy was a nationalist, is a Congress person. I mean, the old Congress school. He would always dress in white, and had this made in India before it became so popular recent days. At that particular time, he wanted to make silicon in India because of its importance in semiconductor industry, and in fact got associated with the Mettur Chemicals in Tamil Nadu and established a silicon plant in Mettur Chemicals. Professor V. Krishnan worked on a number of macrocyclic rings, particularly porphyrin. So I'll just show you some glimpses of these people. So you have the Organometallic Chemistry, which is a book written by Professor Mehrotra and Singh. Of course, his work on metal alkoxides is today very, very important, because many of them serve as substrates for nanoparticles. And about silicon technology in India, if you have, again, this article is, you can access it from Current Science because you can freely download it. This is a tribute to Professor Vasudeva Murthy in terms of how he, along with another colleague in physics and Indian Institute of Science, Bangalore, developed the silicon technology in India. And there are many, many papers of Professor Animesh Chakravarti. I'm just illustrating one of them. In terms of his contributions to coordination chemistry, it's unparalleled in the country. And one of my colleagues, Professor T.K. Chandrasekhar, who was with me at IIT Kanpur, for his PhD, worked on porphyrins. You can see this paper in Inorganic Chemistry in 1981. And later in his independent career, developed several of these expanded porphyrins, also with which contain not just nitrogen, but other elements like sulfur and so on. So expanded porphyrins, which are called with different names, for example, octaphyrin, which are called sapphire because they exhibit different colors. Among the physical chemists, we had a very good start in the country, but at ISCS Kolkata, Professor Sadhan Basu was probably the first person in India who introduced quantum mechanics in chemistry, and later very quickly followed up by Professor P.T. Narasimhan, who was at IIT Kanpur. He was a physicist who came to the chemistry department and in fact made quantum chemistry extremely important, fashionable, and in terms of both the teaching as well as doing research. And the Professor Rohat K. Mukherjee, who was at Calcutta, was another famous physical chemist. And so Professor Mehit Chaudhary at ISS Calcutta worked in spectroscopy. And more recently, we have Professor Deshiraju, who is a crystallographer working on supramolecular synthons and the crystal engineering, and Professor Biman Bagchi, who is one of the most outstanding theoretical chemists in the country, working on many aspects, but particularly, for example, on molecular dynamics and so on. So just a couple of examples of these colleagues' work. So Professor Gautam Deshiraju, for example, has an Outlook article in Angamantashimi recently, co-authored with Ashwini Nangia, on crystal engineering and outlook for the future. And this is one of his most famous articles, Supramolecular Synthons and Crystal Engineering, with I think with several citations to its credit. And Professor Biman Bagchi has written a number of books and also a number of publications. One of his recent books is Water in Biological and Chemical Processes. And one of his, among his many great papers, one of them is the sensitivity of polar solvation dynamics. And of course, experimentally, this polar solvation dynamics was proved by Professor Kankan Bhattacharya, also at the Indian Association for Chemical Cultivation of Science. In materials, I think we have really a giant. There is nobody to compare to him in the country. Professor Sena Rao, he has 1,770 publications as we counted just most recently, with an H index of 160. He has written 53 books. He worked on all aspects of material science, ranging from transition metal oxides to nanoscience to energy materials. And there are other colleagues like Professor D.D. Sharma working on luminescence, I mean, various aspects of nanoscience and so on. So I think, I have not done justice, but what I have shown you is since P.C. Ray, chemistry research in India has been actually reasonably good. In fact, today we rate among the, we come in the top 5 countries in terms of the number of publications, even in the quality of publications. But we have to guard our position and in fact improve. And this can only happen if there is continuous input in science. If input in science is at any point of time slowed down or broken, because science we can suddenly slide down, and science always requires nurturing, and it's like a tree that gives you fruits after some time. If you are expecting fruits immediately and then you are disappointed, and therefore you stop funding to science, that would be the greatest mistake that any country can do. What has chemistry done to Indian economy? In chemical industry, I already told you that this is the first chemical industry that is present, but we have so many chemical industries of different types. Now, this is, for example, the Asian Paints, which makes many things, including paints. Pharmaceutical industry, I take an example from Hyderabad, Dr. Reddy's, from Gujarat, Sun Pharmaceutical, and many more. Petrochemicals industry, this was originally the Indian Petrochemicals Corporation Limited, now taken over by Reliance. Tata Chemicals. So there are so many chemical industries. In fact, this is an opinion article published in the newspaper Hindu on May 7th, 2020, which it's very interesting. It says that in 1969, Indian pharmaceuticals had a 5% share of the market in India, and the rest of the 95% share was global pharma. That is industries outside India. By 2020, Indian pharma has 85% share and global pharma 15% share in the Indian market. Over the last 50 plus years, in terms of both meeting the domestic needs And in fact, as well as building a leading position in the global pharmaceutical landscape, Indian firms have been successful, in fact, very successful. India already contributes over 20% by value to the global generics market, with Indian products contributing over 40% of US drugs. In fact, India is also doing a kind of a social service, because many of the generic drugs are viable and economically viable for many third world and developing countries, particularly in Africa. And the contribution to of Indian chemical industry to Indian economy is roughly $37 billion in 2019-20. If you totally add up both directly and indirectly, it's about 3% of the national GDP. And you can split it up into various sectors, and each sector, I mean, you can take any economic sort of breakup of this. We have we are the third largest consumer of polymers in the world, the fourth largest producer of agrochemicals in the world, the sixth largest producer of chemicals in the world, and so on. So I think it's a good place to stop. I see that we are just about the hour. And so essentially, therefore, those of you who are embarking on a career in chemistry, this, as I said, this particular field is only going to develop, particularly in the 21st century. Chemistry is recognized as a central science with linkages to biology, with linkages to materials, with linkages to physics, and with its own inherent strengths in terms of being able to generate medicines, agrochemicals, fine chemicals, specialty chemicals, and so on. So both in terms of what it can contribute to understand fundamental problems in science, and also to immediate applications to society, I think there is nothing like embarking on a career in chemistry. So on that note, I will stop. And if there is anything that you would like to ask me, or if there are any questions, I'll be happy to answer.
Thank you, sir, for your very enlightening lectures, and from the time of PC Day to the modern era, and the development of Indian the chemical industry and so on. And so now the students are can say few questions if you have. So please ask sir one by one.
Sir, can I ask something?
Please.
Something.
Yeah, please. Sure.
Sir, is anyone there? Means who was the inspiration of PC Day?
So who was the inspiration for PC Ray? So in India, when he started the lecturer Alexander Pedler was the person who really most influenced him in terms of taking up a career in chemistry. That is at least what we obtain, what I could glean by reading the literature on him. When he went to Scotland, there were many, including this Alexander Graham Brown, who was an organic chemist, but who influenced him considerably. Then when he returned back, most of the things that he developed was indigenously developed, but taking inspiration from people, many great people at that time, including Berthollet and many other people whose contributions in various aspects of chemistry were well known to him, and he took inspiration from them.
Okay, sir. Thank you, sir. Thank you for answering my question. Thank you, sir.
Sir?
Yeah.
Sir, what are the careers that we can pursue in chemistry except research?
So that if I understand your question, you want to be in a chemistry profession, but you don't want to be involved in research. That means then you want to be like involved in some chemistry related activity. So chemistry related activity can be many things. For example, you can work in let us say aspects that are related to analysis, aspects that are related to quality control, that in various industries, both in chemical industry, ranging to environment. In fact, even in materials like road building, you need to figure out what is the quality of the materials and so on. So there are such opportunities are there.
Thank you, sir.
Hello, sir.
Yes.
Sir, I want to know about career in engineering after BSc.
Yes, after BSc. So after BSc, if you want to go to engineering, not many places in India. I think the Indian Institute of Science has a 4-year MTech program, if I know correctly. After that, there may be some places which may have which may offer an MTech, but mostly the Indian Institute of Science is one place where I know that there is a 4-year MTech program after BSc.
Sir, what is the chemical engineering?
Okay, you're asking what is chemical engineering as a discipline? How is it different from chemistry? So chemical
Yes.
engineering, again when it started, so chemistry typically we are confined to doing something, establishing a reaction, finding out that a product is formed, and that is the end of it. But let us say a product is useful and you want to produce it on a multi-ton scale. Just knowing the procedure for preparation is not sufficient. There are many other elements, like for example, even the simplest thing, how do I mix things on such a scale? How do I mix things uniformly? And supposing heat is produced in the reaction, how do I take away that heat so that the reaction doesn't go off to an explosion? If heat is needed, how do I ensure that heat gets into it? So how does heat mixing happen? How does material mixing happen? And how do I do it in such a large scale? If there are side products to be taken away on such tonnage, how do I do it? So there are elements of this which constitute engineering. The chemistry knowledge of that goes in is something that has been established very well already, maybe even some decades ago, that is, you can prepare something by this technique. By that, to translate it into this tonnage scale requires all of this engineering knowledge. So there are heat transfer, mass transfer, chemical kinetics, and various aspects of it. So that is where the engineering of it comes in.
Thank you, sir.
Yeah, most welcome.
Hello, sir.
Yeah.
Sir, how can I go in the field of space science via chemistry? I mean, which institutes I have to study for this? I mean, which part of chemistry?
I say it again. Can you just repeat your question? Can you please repeat your question?
Sir, I'm telling, how can I go in the field of space science? I mean, ISRO via chemistry. I mean, which institutes I have to study or which particular topic of chemistry I have to choose to go in space science?
So, in space science, the things that are relevant to chemistry are the propellants and the materials that go into that. So either you go into polymer science or, what are known as materials that are energetic materials, materials that decompose giving energy and so on. So typically, if you have to get into such kind of areas, you have to do a PhD and get into that. If on the other hand, you want to do a BTech type of a thing, then there is actually an institute established by the Department of Space, by ISRO particularly, which is in Trivandrum, which caters to many aspects of it, many aspects of space science. But if you want to go using chemistry as your knowledge, then you'll have to focus on these things. You'll have to focus on propellants or materials that give stability, like for example, even simple things like polymers. So for example, when there are two things that are joined together, there is, let us say, the joining part of it, which chemical is thermally stable, that is that can withstand extremities of temperature and so on. So that sort of a thing you have to figure it out.
Thank you, sir.
Sir,
Yeah.
sir, could you kindly tell me about the scopes of molecular chemistry in India, or which institutes are good for further higher studies in molecular chemistry?
Well, most of the institutes in India pursue molecular science. Every major IIT, every major ISER, then every major research labs in the country pursue. Actually, India is really good in molecular science. Means things that, for example, let's say if you have an organic molecule at a molecular level, not with an extended structure, that is a molecular science. So we are very good in that science. All the institutes, you have a choice of institutes in the country.
Okay, thank you, sir.
Hello, sir.
Yes, please.
Sir, is there anything that inspire you to this part, or you can say inorganic chemistry or organometallic chemistry as your research?
Yeah, so in a sense, I was, let me say, I got attracted to it after I joined my PhD. Till then, for me, I had really no knowledge about it in the depth that I should have. But I was pretty fortunate to be joining in the Indian Institute of Science for my PhD, which is still a really an outstanding place. And so that kind of allowed me to explore various aspects, and I started to kind of enjoy. So the thing to do is, unless you know by either by being in a place, you don't even know what you like or what you don't like. So sometimes you naturally develop it because you have a very inspiring teacher, and that teacher has inspired you to, for example, learn something and you find it very interesting, or you happen to be in a place like I was at the Indian Institute of Science. Then I was really a place which was brimming with ideas, lots of intellectuals were there, and therefore that allowed me to develop.
Thank you, sir.
Hello,
Sir,
sir.
how can I go research line in chemistry?
So what are you doing right now?
I'm in BSc first year.
So you're in BSc. So if you want to go to research line in chemistry, there are typically two opportunities. One is at the end of your BSc, several institutes in India now have an integrated PhD. That means right after your BSc, you can apply to such places. One example is TIFR. The other example is Indian Institute of Science. Then there are many other examples also, which are the integrated PhD. The other possibility is that you do a BSc, then do an MSc, and then you do a PhD. Then there are almost all the institutes in India have opportunities for that.
Thank you, sir.
Hello, sir.
Yeah.
How chemistry is applicable in defense work?
Oh, there are so many. I mean, not just one. There are starting from starting from explosives and starting from coatings, starting from bulletproof wear. So starting from even the food that supposing let us say you're in war and you're in an area where it is not possible to keep supplying you food from the back end, to have food that will last for days or at least a couple of days and nourishes you. So there are various aspects of which are where chemistry is involved.
Okay, sir. Thank you, sir.
Sir, can we go to geochemistry after pursuing BSc chemistry?
Can you repeat your question?
Sir, can we go to geochemistry after pursuing chemistry, BSc chemistry?
Which chemistry? Food chemistry, is it?
Geochemistry.
Geochemistry. I mean, actually, I really do not know, but I think it should be possible. Geochemistry is really analysis, of the chemical constituents, and then analysis and modification of that. So I don't see why not. Actually, yeah, I think you should be able to. Should be possible.
Hello, sir.
Yes.
Sir, what are your thoughts on alchemy and alchemist, and how it is related with chemistry?
So, see, alchemy is a forerunner to chemistry. So, alchemy is really, like when people thought that they can convert anything into gold. So, chemistry started off with like that. When the principles of chemistry, chemical combination, even knowledge of element was not there. But as people slowly learned about these processes, already for example, by by the time Lavoisier entered the scene in France, so alchemy was already going. That is, this more systematic knowledge about chemistry was started to develop, and Lavoisier probably was the first person to develop it. And later, it slowly became clear that there was no magic. There are principles involved which will take you through what people thought that, okay, I can do something and convert metal into gold. We now know that metal, elements can be transmuted, but it is the nuclear reactions. We can't do it by chemical means. So that's so alchemy is a forerunner of chemistry, where people practice it without knowing, but it played a very important role in the development of chemistry.
Thank you, sir.
Hello.
Yes.
Okay, we are at the very end of our program actually.
Okay.
Now it is the time to propose the vote of thanks for this induction program. We have Professor V. Chandrasekhar in this induction program. We have already heard the lecture that he delivered. And we sincerely thank Professor Chandrasekhar for taking out some time from his extremely busy schedule and spending the time with us and our students, and enlightening us with the vast domain of chemistry from Acharya Prafulla Chandra Ray to the present days. So we thank Professor Chandrasekhar once again. We thank our revered Principal Maharaj, Swami Kamalasthanandaji, our respected Controller of Examination, Swami Vedanuraganandaji Maharaj, and other monastic members of RKMBC College, Rahura, for arranging such a nice online induction program. We are also thankful to our technical support team for providing all necessary arrangements and support to organize this induction program. We thank the teachers and staff members of our Department of Chemistry of Ramakrishna Mission Vivekananda Centenary College, Rahura, for attending this induction program. And last but not the least, we thank all the students of the Department of Chemistry of our college, for all the new and old students, for attending this program, interacting with Professor Chandrasekhar, and making this program a success. So thank you, and thank you all.
Thank you. Thanks a lot.
Sir, actually, you have a great link to our Kolkata, sir. Hello.
স্যার উনি কি লিভ করে গেলেন নাকি?
Sir, already leave.
Yes, he
sir,
left.
sir is very busy.
He was very busy, very busy.
So actually, with this few hours, মানে তোমাদের সবাইকে ছাত্ররা যাক ভালো কোশ্চেন করেছো, আমরা লিভ করি, আবার ভালো থাকো সবাই, আর শিক্ষক মশাইরা সবাই আছে, তো আশা করি এনজয় করছো সবাই।
Thank you, sir. So thank this induction program.
Very good, very good, very good.
Very good. Welcome.
Thank you, sir.
Thank you, sir.
Can we leave?
Yes, yes, yes,
yes, yes, yes, you can leave.
স্যার সবাইকে বলি, এবার তো আমরা এন্ড করে দিই, মিটিং এন্ড করে দিলে একবার সবাই লিভ হয়ে যাবে।
ওকে মহারাজ, লিভ করছি তাহলে। হ্যাঁ, লিভ করছি।
ভালো থাকো সবাই, ভালো থাকো।